Welcome to The Explainer. We've got an absolutely fantastic topic today, one that completely reshapes how we look at the daily grind of an engineer. We're diving straight into week 10 of the engineering English curriculum, specifically looking at the outcome-based education framework over at Bengkulu University. When most of us think of engineering, we immediately picture complex circuits, thousands of lines of code, or heavy-duty mechanical stress tests. Communication? Well, that usually gets brushed off as just a soft skill. But today, we're going to look at some hard data and proven structures that show technical communication isn't a soft skill at all. It is a critical, highly technical competency. Honestly, your ability to write a bulletproof professional email or a clear standard operating procedure is just as vital as your ability to design a system architecture. Okay, let's dive into this. 14%. According to the research, a staggering 14% of every single work week is just wasted, completely lost due to poor communication. Think about that for a second. That is literally over half a day every single week, just vaporized by ambiguous instructions, messy emails, and confusing project updates. For an engineering firm, that is a massive bleed on resources. This isn't just about getting your grammar right. It's about pure operational efficiency. And the financial stakes? They get even more tangible. $25. That's the estimated operational cost of a single help desk support call. So, to put that into perspective, when you multiply that $25 by the hundreds or even thousands of calls generated by a confusing user manual or a poorly documented internal process, the numbers absolutely skyrocket. Clear, structured technical documentation can literally save an organization tens of thousands of dollars every month just by preventing those calls in the first place. So the takeaway here is huge. Your writing has a direct, measurable return on investment. And this brilliantly illustrates a concept we call front-loading, by showing you exactly what we're going to cover today right up front. 1. The cost of technical miscommunication. 2. Professional email architecture. 3. Essential components of technical SOPs. 4. Imperative versus declarative styles. And 5. A case study on multimeter calibration. Let's jump into Section 1, the cost of technical miscommunication. Engineering is, by its very nature, highly abstract. We're dealing with incredibly complex theories, algorithms, and invisible forces like electricity. So we absolutely have to anchor our communication in real-world stakes. The macro consequences of bad communication are severe. Ambiguous instructions don't just lose a company money, they jeopardize legal standing and human safety. We're talking direct failures in meeting ISO 9001 quality standards and OSHA safety protocols, which triggers heavy compliance fines. In high-stakes fields, think medical tech or aerospace, a lack of precise communication drastically spikes the risk of malpractice. And on the factory floor, confusing maintenance logs lead straight to severe equipment downtime. The bottom line is simple. Poor writing breaks things. Moving right along to Section 2, professional email architecture. So how do we actually fix this? Well, we start with the daily lifeline of any modern engineer, the professional email. You might send dozens of these a day. But in the engineering world, an email isn't just a quick chat. It's a legal and technical document. To master this, you need to understand front-loading. This is the absolute gold standard in technical communication. It basically means placing your most critical, actionable points at the very beginning of your message. Why? To minimize reader fatigue. Engineers are busy. They're usually skimming your emails on tiny mobile screens while out in the field. Front-loading guarantees they grasp the core issue immediately without having to dig for it. Let's walk through this structured architecture together. A pro email is built on these 5 pillars. First, the subject line. It needs to be a descriptive hook with absolutely zero ambiguity. Tell them exactly what to expect. Then, the salutation sets a credible tone using formal titles. Next is the lead. Applying that front-loading concept we just talked about, put your main goal in the first 2 lines. For the body paragraphs, use active verbs, bullet points, and plenty of white space. White space is your best friend for readability when you're transmitting complex data. Oh, and absolutely avoid all caps. It's universally read as shouting, and nobody likes being yelled at. Finally, wrap it up with a call to action that states clear needs and strict deadlines. No room for back-and-forth confusion. Now, beyond the structure, there's the vocabulary. In a global context, engineers constantly have to translate highly technical mechanical issues into clear business realities for stakeholders who might not know how to code. Using strategic terms like bottleneck is a perfect example. Instead of just saying the code is stuck, you frame it as a business issue. The code review process became a bottleneck, delaying the sprint. Boom, instant clarity. You might also use phrases like scope creep or connectors like the bottom line is. This kind of strategic phrasing acts like a bridge between the engineering department and the management team. All right, Section 3. Essential components of technical SOPs. If emails are the daily pulse of an organization, SOPs, standard operating procedures, are the roadmap. They turn complex operational knowledge into reliable, repeatable execution. A robust SOP is incredibly structured. It has to include the scope, so users know exactly when and where it applies. It needs a clear purpose, defined responsibilities so nothing falls through the cracks, and a comprehensive list of required materials, right down to the specific safety gear. Then you have the execution sequence, your step-by-step guide, and crucially, safety guidelines. But here is the real secret to a great SOP. The writer has to actually get out of the building. You cannot write a realistic SOP from a comfy desk. You have to observe and validate these steps with actual field technicians, or your document will just be full of unrealistic assumptions that get totally ignored on the floor. And speaking of the floor, let's pause here for a second. When we talk about safety guidelines in engineering, especially electrical engineering, we aren't just tossing around best practices. Standard operating procedures for electrical safety, particularly lockout-tagout protocols and grounding, are literally matters of life and death. They are 100% non-negotiable. Your SOP has to be so flawlessly clear about isolating dangerous energy sources that there is zero room for misinterpretation, because, frankly, a misunderstanding here can be fatal. Section 4. Imperative versus declarative styles. Now, what's really interesting about this slide is how exactly we write those instructions to make sure they're followed perfectly. It all comes down to two contrasting styles, imperative and declarative. The imperative style is your boots-on-the-ground approach. It focuses heavily on the how. It's explicit, it's granular, and it tells the user exactly what physical action to take, like set the volts/div control to 1. That is ideal for field technicians. The declarative style, on the other hand, focuses on the what. It's a big-picture, outcome-oriented approach. For example, filter cleanliness must be maintained at 95%. Notice it doesn't tell you how to clean it, just what the end state has to be. That's perfect for project managers. A truly competent engineer seamlessly switches between both of these styles depending on who is reading the document. Fortunately, we don't have to figure all this out alone anymore. The future of technical documentation is heavily leaning into AI-assisted writing. Tools like Grammarly's AI or Talieris Talk to Tally are absolute game changers. They help engineers, especially non-native English speakers working in massive global environments, instantly calibrate their tone. These tools ensure you strike that perfect middle ground between abstract business writing and granular technical instructions. They're literally breaking down language barriers in real time. Finally, Section 5, Case Study on Multimeter Calibration. To truly cement everything we've talked about today, let's look at how language, industry standards, and strict documentation all align in the real world with digital multimeter calibration. See that ratio, 4:1? That isn't just a random number. It's a critical industry standard called the test uncertainty ratio. When you write an SOP for calibrating a high-precision digital multimeter, you must document that your testing equipment is at least 4 times more accurate than the device being tested. Without this documented standard, high-precision instruments suffer from drift over time, and a drifting instrument leads to catastrophic system misdiagnoses out in the field. Let's see how an SOP actually structures this process using that imperative style we discussed. The execution sequence is super precise. First, visual inspection to check hardware integrity. Second, performance testing to verify accuracy. Third, adjustment to bring the hardware or firmware back into perfect alignment. And finally, documentation, issuing a certificate that ensures strict traceability to national standards like NIST. This sequence perfectly illustrates how a well-written SOP transforms a totally abstract quality requirement into a flawless, traceable, physical action. We have covered some incredible ground today, from the massive financial cost of poorly written emails to the life-saving structure of an SOP, right down to the exact linguistic style you need to be using. So I want to leave you with a final provocative thought. Is your technical communication a bottleneck holding back your team, or is it a structured bridge, ensuring ultimate safety and operational efficiency? Remember, whether you're still a student or a seasoned pro, the written words you produce carry the exact same weight, the exact same cost, and the exact same responsibility as the physical circuits and systems you build. Thanks so much for joining me on this explainer. I highly encourage you to go back, look at your recent emails, and start applying that front-loading technique today. Keep learning, keep structuring your thoughts, and I'll see you in the next one.